Hello everyone, how are you all? My name is Vishal Kumar. Welcome to the YouTube video. So today we are going to start next lecture of the machine learning, and in this lecture we are going to discuss about R square and adjusted R square. Right? So what is R square and what is adjusted R square, and generally why we will just learn this concept. Okay, so let us understand. So this one is a one of the performance metrics you can say, and in this you can just check whether like only to check in the regression case, right? So generally we are going to check in the linear regression, and also you can check for any regressions. Okay, but right now listen. So here this R square and this adjusted R square means it will be help you to to increase your vector performance. Means like, for example, some of the features are coming, extra features, if you will, it will be added. Means how it will be get impact to that target variable. Are you getting that? So there is a dependent variable and there is a small independent variable, right? So that independent, if new independent variable will become, then how it will be impact to that dependent variable. So if it will be means some of the independent variable or some of the features which is not not much more important, but in that case, okay, in that case, so it is affecting to our accuracy. Okay, so no need to just increase the accuracy. Okay, so for that case only, so we are going to use this R square and adjusted R square, means to perform well, means to check our performance of our model, right? So I'm just taking the example of the linear regressions, and let's start. So here, first of all, I'm just going to discuss all about that R squared. So what is R squared? Listen, R square is nothing but what? R square is like, so the it will be check for example, the formula is 1 minus, okay, sum of square residual divided by sum of square total. So first of all, understand what is the sum of the residual and what is the sum of the total. So if I will just draw the graph is like this. The graph is like this. For example, so assume that this one is the what? This one is the one on data point. You can say this one is the one on data point. Okay, so according to this data point, I'm going to just draw one line, and the predictor line, this one is the predictor line. Now see. So here the difference between this actual, the blue point is the actual value, and this green line is nothing but the what predictor value. So I already explained in that previous part. So here, this difference between this, let me change the color. Okay, the difference between the blue and the green is nothing but the what? The error part. So our aim is what? Our aim is to minimize this error. Our aim is what? To minimize this error. Yes or no? Okay, so if you will just minimize this error, then our model is what? Very good model. But the time will become, so if you will just minimize, means if the data will be like this, if the data will be fitted like this, okay, so this condition is what? Means the model is created like this, means it is what? There is a no error. If it will be 100%, then what? It will be one big problem, which is nothing but the overfitting problem. So what is the problem in overfitting? So we'll explain in the next video. Okay, so I will upload that difference between the overfitting and underfitting. So just remember that one. So overfitting problem is create what? So in the training model, the accuracy is very good. In the training model, the accuracy is very good. But whenever the whenever the test concept will become, the accuracy is very, very low, actually. Because Because if I will just bring the one test model is coming, means one data point, new data point is coming. Now see, what is the difference between here to here? So this one is what? For the testing case is what? For the testing case, the accuracy is very, very low. Right? So for the R squared error, so we have to just calculate the residual, means R square, sum of the square of the residual and sum of the square of the total. Right? So here, what I have to do? So what is the sum of the square of the residual? The sum of the square of the residual is nothing but what? So here, sum of what? Let some I value is till 1 to n, means n number of data point is there. So here, what you have to do? So actual value negative of what? So y hat of whole square. So here it will be measure, it will be give the value, it will give the value, okay, means it will give the error, minimal error. What is the difference between the actual value and the predictor value, right? Right. So here, this formula will be help you out to measure the difference, means to calculate means total how many errors is there. Okay, so now here what will be happen? Listen. So this one is nothing but all about like sum of the square residual. Okay, so then what about that sum of the square of the total? Yes. So listen. So here what it will be happen? What it will be happen? So it will find the average of y. It will find the average of y. So let this one is the y and this one is what? So this one is the y. This one is the x. So here, so we have to find out the average of y. So now let us assume this one is the average of y. This one is the average of y. So here I'm just giving this one is the y dash. Right? Y dash. So what is the formula then? Sum of the total formula. So here sum of I equal to 1 to n, which is equal to y dash whole square. So it means what? It means what? Listen, what it will be happen. So just see. So here the blue, here the data points are there. Yes or no? Here the data points are there. So now see, just tell me. So the difference between this one is very high, or the difference between this one is very high. Obviously, this part is very high. So that's why remember one thing. So what it will be happen? Okay, there is a one big question. So in your exam, so maybe this type of question will become. So if in this residual sum of this square residual part, which will be means the if the difference of the error which is very low or very small, you can say, okay, and this part is what? This part will be become bigger because this part is big now. This part is the big. If this case will be there, means small divided by big. Okay, if this case will be there, means what? Then it will be best. Then this model is very best fit. Okay, so it will be give the accurate answer. But the point is what? If the best fit line will be like this, assume that the line is what? The line is like this. The line is like this. It means what? The difference is what? Very, very high. So it means what? In some case, what will be happen? And somehow this part is very, very high part, and this part is very, very low part. So here the model is not good. Here the model is not good. All right. So our aim is what? The best fit line is what? The best fit line is always this. Remember this part. The sum of the square of the total is always greater than to what? Sum of the square of the residual part. Clear, everyone? So it means so what? So if 1 minus, so if any value will be there, if sum of the square of the residual divided by sum of the square of the total. So if any, this one is what? This one is the small divided by bigger. So automatically the small part will become. So let us assume, so I'm getting the 0.20. So it means what? So 1 minus 0.1 minus 20%. 1 minus 20%, 0.20 means what? 0.80. Okay, 0.80 means what? 80% accuracy will become. Okay, 80% will become. But if this part will be very weak, obviously the accuracy percentage will come, na? Are you getting na? So that is the concept. So let's go for the adjusted R square. Okay. So if I'm talking about that R square range, okay, the range is what? Negative infinite to the 1. The range is negative infinite to the 1. Okay. So let's go for the adjusted R square. What is adjusted R square? So I'm taking one example. So let's take an example. What? So the location, the mm, the number of bedroom and the house size. Okay, and then the price, you can say. So I'm going to buy one. I'm going to buy a buy a like one house. Okay, so let assume which is present in the one of the like mm, one of the town. Okay, you can say the Bhubaneswar, yeah, any like a big town. Okay, Delhi. Okay, so if you want to buy any house in the town, so obviously the price is very high. So here our aim is what? So in this problem statement, our aim is what? To find out which feature. So these all are the independent feature, 1, 2, 3, and this one is the dependent feature. The price is always depends upon the locations and that house size, obviously the house size. Okay, all these things. So now here our aim is what? So we have to find out, means like so if so I'm just going to buy one house, so only the house size is given to me, obviously. So I will just go to the house size. So if the house size is very big, and obviously the price is what? As compared to the size of the price will be increases, yes or no? As compared to the size also, if the size is very small, the price is very small. So here assume that the R square, the if you will just calculate the R square value, so let assume that it is giving like so 70%. Okay, so it is giving the 70%. So think that, so another, so the number of bedroom is there. So is the number bedroom is affect to the price? Yes. So if the house size is there, okay, small amount, not like big amount. So number of bed, total of number of bedroom is what? So let assume the bedroom is the 3 BHK. Right. So here, so if another feature is added, so then see that again. So if we'll just calculate the R square, obviously it will be slightly increase. It will be slightly increase 74%. Similarly, go for the locations. Either whether the location will be affected, obviously the location will be affected. Okay, so now, so if you will just go to buy that any house in that location of village, okay, so obviously that part is very low as compared to what? The town part, right? Any big city part. So here the location is affected the price here. So it means what? This part is very important feature as compared to what? This one very important feature towards the price. So here again the R square value will be increased again. Okay, so it means let us 0.80, which is the 80% accuracy. Now just see. If I will add, so this dependent, all dependent independent variable is what? So it is important to the dependent variable. But can you just tell me this number of people is important? How many number of people will be means stay in the house? So is it important to means like increase the price? Means I want to buy a house. Okay, so whether it is whether this feature will be important to buy the house, means whether the price will be increases? No, because no matter how many person they are just staying, the matter is what? Means like what is the house size? So if the house size is very big, then number of people will be stay. So totally depends upon owner, na? Right? So similarly, so if there is another feature is there, gender. So whether this feature will be important? No. It will, whether it will be affect to the price? No. But in this case, whenever just I will added this feature, the number of peoples, so the R square value 100% it will be increased slightly. It will be increased slightly, means 82%, 2%, let us assume. Similarly, if again I'm just adding this gender part, so for the gender case, the R square value again it will be slightly increased. Let 84%. So it means what? So whenever, if you will just add any new independent variable, okay, independent feature, the R square value is continuously increasing. So no matter that feature is very important for us or not, but R square value is increasing. So this is creating one problem. So how it will be, means like to penalize this one? So here new concept is coming, that one is the adjusted R square. So adjusted R square is coming and saying that, okay, don't worry, I'm here to penalize this one. So now let's go for the formula. So what is the formula? So 1 minus, so 1 minus, so 1 minus R square, and then n minus 1 equal to n minus p minus 1. So here this part is what? This part is the n is the number of data points, and here p is what? P is nothing but the independent variable. P is the independent feature, you can say also. So if you will just add, listen, so independent feature value means if P value is the 2, okay, so the feature value is in denominator, it will be continuously decrease the part, decrease the accuracy. If this one is the 70%, then it will give what? 68%. If this one is the 74%, then it will give the 72%. The adjusted R square will be this one. So this one is the formula. So if you will just increase the P value, means number of feature will be increased, then it will be decreased, because the denominator, in the denominator this feature value is added. So hence it will be decreased. So hence the adjusted R square, for this case, the adjusted R square is what? So near to 78%. Okay, so if means like unusual feature will become, so no matter, it will be not increase the accuracy. This is the point. Clear everyone? Right? So this is all about this R square and adjusted R square. So if you are having any doubts, so you can comment me. Okay, and do one thing. So if you like my video, so do subscribe and like and share also to your friends. So it will be very helpful to your friends. And if you want the notes, and you can just easily join my Telegram group. Okay, and you will get notes there also. And you can, if you want to connect with me, you can just go to the description part. Also, you will find the WhatsApp group. You can easily connect with me. So that's a bye bye. So we'll just meet in the next video with a new concept.